Alright, it says I'm live, and the stream status is good. Alright, I think we are live. Are we? Are we? I don't know. Hey everybody, welcome once again to ADL, but it's no longer Astronomy Daily Live. If you look above me here, it says Astronomy Discourse Live. So hey, welcome to Astronomy Discourse Live. And I have to remember to look this way. So when I was here, I'm going to tilt that up a little bit too. There we go. When I was doing this from home, this camera was over here. Was over here, and so I've sort of gotten into the habit of looking to my right, but now I've got to look to my left. I suppose I could do that. You can see all the garbage behind me. So hey, welcome everybody. Glad everybody could stop in. Let me. Oh man, there's not a lot of room. There's not a lot of extra room over here, and it's a little slanted. For now, I'm gonna put you back. So yeah, hey, hope everybody's doing well. I can pull up the chat here and actually watch at the same time. So 9-inch Colas, hey, nice to see you. Atta, hey, great to have you back. It's great to be back. This is going to be a pretty short live stream, I think, mainly just because I've got to get comfy live streaming in this kind of environment. It's not as if it's a busy place or anything, but it's new, and as you can see, all the garbage behind me and all that, messy desk and all that. So Atta, nice to have you here. Niji, hey, great to have you there in the chat as well. Tom, hey, great to see you there too. And Uncle Bill, hey, great to have everybody there. Yeah, you know, earlier today I was trying to, I just sort of had it in my head that, you know, I could probably stream to YouTube and to Twitch at the same time. I mean, what's the big deal here, right? And so I went around and around with that a little bit, and finally realized that no, I really can't. I would have to, you know, that's something that you know, the capabilities here just aren't here. And actually, what others use for that is some kind of a streaming service. So you know, I would send this one stream to them, and then they would stream to all the other ones, and you know, that's just not going to happen for now. So how do you like my nice shiny ADL? It still of course says, you know, Astronomy Daily Live, but yeah, you know, since I'm having to do this from work, I'm just not going to be here every day. So technically speaking, it is not going to be a daily live stream. Kara H, hey, what's up? Nice to see you. Glad to be back. Really glad to be back. What I want to do really quick is do that. So okay, cool. So yeah, here, I'm just going to give you not exactly a tour of the lab here. This is an electronics lab where I've been working for at least a few years or so, trying to do electronics. You know, I'm an astronomer, but I wear many hats, and one of the hats, one of the new hats that I've put on over the past couple of years is electronics technician. So I actually repair these amplifiers for these devices called nuclear magnetic resonance spectrometers, and we just fixed the amps. I'm looking around to see if we have one that I can just sort of grab, and there really isn't one, so I won't show off that. But the one thing that I've never been able to show you, oh, Starhopper just flew, huh? Very cool. Yeah, they, yesterday I was watching, and they had the countdown, right? And it was counting down, it was counting down, and it got to 0, and nothing happened. Nothing happened at all. So it's like, oh man. So yeah, I'm really glad that they um, uh, yeah, mine is shiny because I am cosmic. That's why. That's why. So yeah, actually this is a custom job. A coworker here is getting into making T-shirts and mugs and hats and all that kind of stuff. Um, and he's still sort of in the experimental phase. He's not really able to do any kind of production yet, but he wanted to experiment a little bit, and so yeah, I got the nice shiny one here. But here's one of the things that I've never been able to show off, and that is one of my great big awesome mugs. Isn't that great? Now that is a mug, right? That's a mug. So cheers. No ignition. No ignition. All right. Bummer. And the other thing that I've never been able to show you because it's been here is the second piece of mirror glass. So this is called Zero Doer, and as you can sort of see, it's not exactly clear. It's got this sort of bluish, opaque type of stuff. So, but this is the kind of glass that is used in a lot of the large mirrors that are currently being used. And yeah, I've never been able to show this to anybody here on this live stream because it's always been here at work. So there it is. Happy to finally show that off. So yeah, I've got the mug. I've got this is definitely a day for dihydrogen monoxide, the good old H2O here. So cheers. All right. Well, it's great to be back. Like I said, this is probably going to be a little bit of a shorty, just because, yeah, just sort of getting used to this kind of environment again. So, yeah, it does sort of look like a big diamond. It's just a chunk of glass. This is how it comes in to facilities like the Mirror Lab at the University of U of A, and they have to go through all these chunks of glass and look for little flaws, little bubbles and stuff. Now I've dropped this a couple times. You can sort of see, there's a drop right here, and there's another one right there, and there's a chunk out of the top. It's kind of hard to see there. But yeah, oh yeah, and then there's a big chunk. Can you see that? I don't know if you can see that or not. There's a big chunk right there. So, but Not going to have to worry about things dropping on the floor here because there are no cats here. There's absolutely zero cats here. So, all right, well, cool. Well, hope everybody's doing well. Things are good here. It's it's um, it's warm. It's warm. Um, we can actually take a look at that. For those of you who don't know, if you do over on the chat, if you do a command bang my weather and then your zip code, like I'm doing right now, you can Nightbot should respond. So yeah, let me know how the video is and the audio is. The only thing that I don't have today, and that I'm really pleased that I'm going to be able to do this, but I'm going to be able to mix in some background sound. So yeah, I am going to be able to play some spacey music behind that. Andy Cowley, hey, nice to have you back in the chat. All is well. All is well here. Things are beginning to wind down in one way and wind up in another way. So yeah, it's the usual insanity. So that's just how that kind of thing goes. But yeah, this live stream is still all about sharing the passion for all things astronomy, space, science, all that. So yeah, let me make sure, let me know how the audio is. Is it too high? Is it too low? Anything else? Yeah, just let me know. It looks good and it sounds great. Good. Thank you much. Yeah, this OBS is something that I've wanted to start using for a really long time. It's just my bandwidth just wouldn't allow it. But here at work, the bandwidth is slightly better, so the video is going to be a little bit better. And now that I can get onto OBS, there are lots of interesting things that can be done, like mixing in some background sound and creating these different scenes. And I guess that's probably what I want to get into next, is just switching to at least one of the scenes here. And I thought that what we can do, reach over and grab the, I've got to find a better way to, there, okay. I just shrunk my my chat down a little bit because how the chat was, I sort of was only seeing one half of my screen, so I was like, is that? But okay, so now I can see the whole thing. I can see all the gizmos behind here. This thing is a network analyzer. One of the things that we're sort of getting into here is antenna design, and a network analyzer apparently uh, um, works with that really well. So cheers. All right. So one of the things that was definitely lost when Google Hangouts went away was my ability to share my screen, and so I've got that back with this software. It, um, the other thing that I want to bring back in, of course, is panelists, and I think one option, and there are probably lots of options here, but I think one option that I want you all to consider is getting onto Skype, because I think with Skype those can be sort of different windows on my screen, and then I can put all those into a scene, um, and then we can have like a panel thing. So yeah, so that at least is the thinking there. But yeah, I mean, most importantly right now is me just being able to share my screen. And so I guess without further ado, let's go ahead and do that. What I thought that we could do just for this first um, return to the live stream is take a look at the latest astronomical, excuse me, um, the astronomical articles over on archive.org. So that's a great repository for sort of the latest and greatest in all things astronomy and lots of other things too. So, okay, here we go. We're going to switch scenes. Are you ready? Are you ready? Wait for it. Here we go. Here we go. Isn't that cool? So I'm still here in the bottom. So you can always watch me if you want. I don't know why you would want to, but yeah, this is just the browser now. And so I'm going to pull that up for myself. So I'm actually over here. And I guess what I'm going to try to do is keep the, yeah, I'll try to keep the chat um, um, coming in too. So could I use Discord for audio only? Yeah, I definitely could, and there actually is an audio channel there, which you all can use pretty much whenever you want too. So yeah, that's always a possibility. Anyway, so here's archive.org, and this is just a great repository, like I said, of all the latest and greatest papers, scientific papers, and it goes through lots and lots of things, right? Physics, mathematics, computer science, quantitative biology, quantitative finance, statistics, electrical engineering, system science, economics. So I greatly encourage you all to go into all of these, right, and see what is going on with all of these areas of science and math and all of that. But rightly so, astrophysics is right at the top. It's the first one. So that's exactly how it should be. And so I really like that. So these new papers are put out every weekday, starting, they're usually out by 1 or 2 hours UTC or so. So a new set should be coming out in a few hours. And I guess that's sort of the other new thing about this live stream is that it is going to be going on at 22 hours UTC. So it's no longer 2 hours UTC. It's 22 hours UTC on the same date. So yes, it is the 27th of August 2019, both in UT time, right? It's 22:17 UT time on the 27th of August, and I'm in the state of Arizona, which is always 7 hours behind UTC. So here it's 3:17 p.m. Also on the 27th. So we're no longer going to have to think about exactly what day it is and all of that. And I appreciate that kind of confusion, but I also understand that kind of confusion. So that problem is a little bit solved as well. So all right, let's dive into these new astrophysics papers, and what I like to do is just sort of go through them and see if there are any sort of interesting looking titles, and if there are any interesting titles, then we can look at the abstracts, and the abstracts are these paragraph long things. They're sort of like executive summaries of the entire paper. So yeah, let's just sort of go through these. There's usually 40 or 50 new ones every single day. So I'm going to grab my big mug here, which is actually almost out of H2O, which is not great. But all right, cheers. So let's take a look here and see if there's anything interesting here. Probing the theory of gravity and nonlinear growth. There's a lot of things to do with probing and gravity in these first few articles here. Fade to gray, systematic variation of the galaxy attenuation curves. The intriguing polar EU Cancri in the eyes of Kepler-2. What is so intriguing about EU Cancri? So let's just click on this, and let's see. And I can zoom in like I always did. So we present the light curve of EU Cancri, the first published analysis of a Kepler light curve of a polar, not a polar, but a polar. And didn't that term come up somewhere before when we were talking about polars? I don't remember exactly what a polar is again, so we'll have to find that out. So although EU Cancri was extremely faint during campaign 16 and 18, its light curve showed a large amplitude pulse that lasted for half of each orbit, which we interpret to be light from an accretion region that rotates behind the limb of the white dwarf for half of the orbit. Okay, well that kind of sounds a little bit interesting. Why don't we, I mean, if nothing else, I'd like to see the light curve, and this is from Kepler, the spacecraft that I think is Kepler still going, or is it almost on its way out? I don't remember now. I think it's done, but Kepler was a spacecraft in orbit around the Earth. Was it in orbit, or was it at one of the Lagrange points? Man, I'm really not remembering all that well. Anyway, and yeah, this is K2. So there was an original Kepler mission that just looked at one portion of the sky, a very, very small portion of the sky, looking for stars that dimmed in faintness, and that has sort of been assumed to be a body of some sort of planet moving in front of the star, and the combined light from the star therefore drops a little bit for a certain amount of time. As that planet moves in front of the disk of the star, the brightness of the star is going to fade a little bit, and then it's going to brighten up again. And so Kepler was all about that. That's called a transit. And it had a primary mission and a secondary mission. And throughout it all, I think they've discovered something like 3,000 or 4,000 extrasolar planets, supposedly. just by observing these transits. Now, to me, that's sort of a red flag. In order for, the the planet and the star and us to be completely lined up, so we actually see these planets transiting the stars. That's a big number. Over 4,000 of these. When the orbits of these planets can sort of be all over the place. So why is it that there's so many that seem to line up really, really, really well? I don't know. But could those dips in the light curve be something else? Um, well, they say not. So they've taken the data, they've matched it to these models, and the conclusion is that they are planets. Now, the skeptic in me, right, says, well, it's all we're looking at is a light curve. Now we're sort of getting into spectroscopy a little bit now, and actually, um, being able to look at how the spectra of these stars change as these transits occur. So more information will convince me a little bit more that these are actually planets. Whether they are or not, I expect that there are planets around every single star, right? So I'm not incredibly surprised that there are planets. I'm surprised that we're seeing as many as we are. um, but cool, I'm down. So let's look at a light curve here. They probably do have a light curve. So here's the actual paper. Um, it looks like it's going to be running in the RNAAS, which is a really, really, really short format kind of thing. These are the research notes of the American Astronomical Society. So those are limited to, I think, like 1,000 words and one picture. But I already saw that there is actually a light curve. So there we go. Phase averaged orbital light curve. And they actually did that's kind of cool. So they actually did a sort of a 2D light curve where you have phase along the x-axis and then time here. So let's see. It looks like the earliest is at the bottom and the latest is at the top. And as you can see, there are, for the most part, it seems to, follow the same pattern. But there are some differences in here. You can see that sometimes it goes a little bit longer here. Sometimes it goes a little bit less. But overall, yeah, that's sort of what we're seeing. And this is they're calling this a relative magnitude. So yeah, these units are a little weird to me. It goes from 0 up to negative 0.5. So but it's kind of interesting. One of the many things that you can sort of see with these light curves, and sort of get some additional information about the transiting object, is the shape of these light curves. And as you can see, it's got when it goes dim, I guess you can call that dim, although this is a negative here, so I'm not quite sure how to interpret that. But pretty flat here. I'm sort of thinking that this, for some reason, I don't know why they would do this, but it sort of seems, I don't know. It sort of seems to me that these events here are the transits, and this is when we're just looking at the single star. Wow, that's really hard to interpret. They've got this sort of upside down, at least according to my head, at least. But maybe my head is upside down. Who knows? um, so let's see what the thing says. Oh, yeah, so this is just the phase average. So a phase, okay, and they're actually going from zero to 2. So going from 0 to 1 means that it's gone all the way around once. So you know, this object, whatever it is, they're calling an accretion disk, has gone around this white dwarf star once in a phase of 1, and then they're actually showing another one here. So kind of interesting. And then the bottom, as I said, is a 2D one showing phase versus time. So it's kind of interesting, right? That it looks a little darker here and again, I'm not quite sure if this is the transit or if this is the transit. I don't know. Anyway, so then they can do transit timings to see if it's changing over time, you know, if there's any precession or anything. But yeah, that's just a short little thing. Nice to see a light curve there. So it's saying period humps every 2.1 hours. So that would be one phase. So from going from 0 to 1, this amount of time, I guess, is 2.1 hours. Okay, well, that's kind of cool. Pretty cool. Keep going here for a little while. The Micro X sounding rocket. Density distribution of photospheric vertical electrical currents in flare-active regions of the sun. I gotta say that you know, I'm happy to be seeing a little bit more discussion of electrical effects when it comes to all of astronomy. I think that is one aspect of astronomy that has been very hugely ignored. So yeah, and there are lots of things on the sun that are pointing more towards electromagnetic. Well, you know, especially, you know, the electrical effects. You know, we're already seeing and know about the magnetic effects, but you know, the thing that a lot of astronomers don't talk about is the fact that the only way that you can have a magnetic field is if you also have an electrical field. So you know, those two go hand in hand. So yeah, it's nice to see that. Signals survey description. So this is a survey of some sort. They're calling it the too big there. Signals. So that's Star Formation, Ionized Gas, and Nebular Abundances Legacy Survey. It's SIGNALS. That's great. Where are we? Here we go. Testing the limits of particle acceleration. New star tests of sterile neutrino dark matter. Wow. So capturing cosmic ray research and researchers with art. Okay, well, Astronomy Discourse Live is all about art. I think that's one of the other things that astronomy and science has missed out on, and that is, trying to use art to sort of talk about all of these things. We have these beautiful astro photos, and all of that, but there's so much more that can be done. Let's take a look at that. Capturing cosmic ray research and researchers with art. So that's kind of a curious thing. Let's take a quick look at that. I'm going to check the chat really quick. Yeah, I'm looking in the chat, and that reminds me that I still have a little bit of stuff over on my Teespring site. I've got some astro-art over there. I definitely want to be adding more as time goes by, and especially now that I'm sort of back up and running with this. And there's also my Patreon page, and got to say that Niji and Tom and Atta are at least 3 Patreons over there. So um, um, so I'm doing some pretty interesting work over there, looking at some photometric data of Jupiter's moons that I actually collected back in 2014, and just recently, this past June or so. And I'm going to be adding more as time goes by. So if you're interested in supporting my research, if I had my way, I would be doing astronomical research full-time, all the time. But it sort of is looking like the only way that I'm going to be doing that is with your help. Now, most scientists get their research funds through like the National Science Foundation or other government-run things like that. So you are supporting all of those astronomers in an indirect way. The government comes and takes your tax money and then doles it out sparingly. So my approach with this Patreon thing is more direct. You can fund me directly. So if you're interested in that, feel free to go over there and take a look. But let's take a look at this artwork here. So I guess this is from the Proceedings of Science, which I don't know if I've ever heard of the Proceedings of Science. So let's see here. I'm going to zoom in a little bit again so you all can see. We describe our experiment with an alternate approach to presenting cosmic ray research. Now, cosmic rays are very cool things. Nobody really understands them all that much. And actually, to most astronomers, they are, really annoying because they mess up data. But in this case, these folks are actually looking at cosmic rays, and apparently they have done something interesting, artsy-fartsy with it. So let's keep going here. The goal was to more widely promote cosmic ray research and attract diverse audiences, especially those from groups that are sorry, distraction there. Those that are underrepresented in science or that do not have experience attending science outreach events. So, distractions. So, all right, let's take a look at what they're doing here. Alternate approach to examining cosmic ray research and the people who do it. Very cool. The artists work with Madsen and the other IceCube scientists and staff to create messages, which consists of 2 original installations on display. Event Horizon and Messages from the Horizon. So there is, I don't know if that's one of the artists. I keep going down here. I want to see some of this artwork. Oh, excuse me. It's too early to be doing that. Artist bios. Okay, so here's I guess some of the artists, does it say? Yep, portraits of cosmic ray scientists. So these are cosmic ray scientists. Wow. Messages from the Horizon. Worked which consists of a kinetic persistence of vision display. Combines embedded computers with screens and custom electronics. So, okay. Alright, so you got these like spinny things here. Working on the install. So this is Messages from the Horizon. This is, okay. While in operation. Okay, so Messages from the Horizon is an abstracted and collapsed form of the universe within the space of a small room. It's an expression of the process of astronomical observation, knowledge acquisition, and the human condition in the universe. Most of what we wish to learn about our universe falls outside of what we are able to perceive through our senses. Ultimately, all information gathered from our instruments must be scaled and transformed so that it can fall within the range of our perception to be understood. In this case of astronomical observation, we do this by slicing the electromagnetic spectrum and comparing significant simultaneous events in our universe in energy, location, and time. The relation of the totality of what is present in the universe and what is perceivable through our senses highlights the edges of what is known, knowable, and unknowable in our universe. From this perspective, okay, blah, blah, blah. In the installation, 3 semi-transparent displays represent black holes located in the distant reaches of our universe using a technique known as persistence of vision. Okay, well, all right. So, yeah, these are supposed to be like black holes, and they've got these spinning things. So yeah, they're, as they spin fast, our brains hold on to all that, and so they look like a solid piece there. Okay, that's kind of interesting, I suppose. Oh, man, I should not be yawning as much as I am. That's terrible. Sorry about that. Okay, well, you know what? I don't know if I'm incredibly impressed with that. Maybe there's something I'm missing here. That's always a possibility, but okay. Well, I don't know. Not too impressed with that. Let's keep going here. I'm going to check the chat really quick. I guess maybe I'm not quite understanding what they're talking about, Atta. That's entirely possible. All right, let's keep going here. The effect of fluctuating fuzzy axion halos. Holy moly. Hubble expansion. The Bardeen-Patterson effect. Don't know what that is. The fifth main sequence, magnetic B-type star showing coherent radio emission. Global solar magnetic field and interplanetary scintillations. Okay. Silicon photomultipliers. Wow, these are getting into some serious, some heavy topics here. Curvature tension. Radiospectroscopic imaging. Wow. So, mid-infrared evolution of Eta Carina from 1968 to 2018. Might be interesting to look at that. Multi-island magnetic reconnection, the S process, pressure profiles and mass estimates. I don't know. I don't remember what Zwicky 3146 is. I don't know if that's a... Yeah, I'm not quite sure what that is. Active regions. It sounds like it's about the sun again. Thermal components and gamma ray bursts. A supernova remnant counterpart. That's kind of cool. Supernova remnants are always moderately interesting. The spaceline, practical space elevator alternative, achievable with current technology. Yeah, so there was just a guest. I think it was a guest on TMRO. Somebody developing some kind of space tether technology. So I sort of assume that this is the same kind of thing. So yeah, they're talking about a space elevator. Yeah, I'm yawning. I'm yawning again. That's horrible. Sorry about that. Well, let's take a quick look at this space elevator thing. See if there's anything particularly interesting about it. I'm sort of skeptical of these space elevator things, mainly because, again, you know, they don't really seem to be talking about the electrical effects and the electrical problems. You know, there are, I mean, huge voltages as you change height, and if you have this you know, conductor that is, you know, 2, 3, 4, 500 kilometers long, you're talking about voltage potentials that are just unbelievably high. And so, you know, even a little bit of current, and the other thing is, of course, you're going to have this wire that isn't stationary in a voltage potential. You're going to have this wire moving, so you're going to have this huge current. I don't know. See, and this is what they always say. Perhaps the biggest hurdle to mankind's expansion through the solar system is the prohibitive cost of escaping Earth's gravity. They only think that there is going to be this problem with gravity, and I'm not buying that. So let's see what they've got here. They've got, it looks like, so fundamental limit of a space elevator is whether, is whether the material can support its own weight over the necessary length. So it just has to be strong enough to you know, be able to hold you know, the elevator up as it's going up. So okay, well, I guess this probably goes a little bit beyond what we can do here in a short amount of time, so I'm not gonna spend too much time on this, but you know, it's worth investigating these kinds of things, just to see what's going on, and you know um, how it's being done and all of that. So that's pretty cool. So they're talking about a thing from the Earth all the way to the moon. Wow, pretty amazing. Isn't that what they're saying here? Is that uh, yeah? By extending a line anchoring on the moon, we can construct a stable transversable cable, um, allowing free movement from the vicinity of the Earth to the moon's surface. Wow. It's you know, it's a great idea, but you know, and obviously without reading this through, I can't really say much, but you know, the skeptical red light is just flashing really bright here. So that's a toughie. Physical constraints on the cable. Steel, titanium alloy. So yeah, you know, they're talking about various materials here. Um, Tensile strength. That's newtons per square meter. So you can sort of see where spider silk falls in that. It's pretty amazingly strong. But I guess there's a few others, and for some reason they've highlighted carbon nanotube, and it looks like it has quite a bit of tensile strength here, 6 times 10 to the 10th newtons per square meter with low density. In fact, lower density than spider silk. Wow, that's kind of interesting. So pretty cool. I'm going to check the chat really quick. Yeah, well, Atta, that's what they're saying. I I I guess they're talking about carbon nanotubes. See if we can get to the bottom here. Spaceline designs, cross-sectional areas. It's got to be pretty darn thick, I would think. So, you know, if you had a cubic meter of this, oh, hold on a sec. Hey, okay. Sorry about that. That's one of the difficulties of live streaming here at work is that apparently on occasion I'm going to be interrupted. So be it. Okay, let me let's get back. I was going on the chat. Yeah, I just wanted to I muted so we could have a little conversation. So, but yeah, I think I should be back. Yeah, audio should be back. Yes, no, maybe so. There's a little bit of a delay, so I'm just gonna keep on a trucking here. Um, let's see. Okay, so spaceline design. Yeah. So yeah, if you have a square meter of material, then you'll be able to support a tension of what is it? What did it say? Uh, 60 billion newtons in a square meter, or yeah, um, per square meter. So pretty good, pretty good. Interesting. Let's keep going here. Spaceline. Let's see if they say anything more here. Tapering cable. Kind of interesting. Tapering cable. Practicalities and possibilities. Talking about the mass of the cable. So total mass 40,000 kilograms. That's not very heavy. That's not too bad. A rational argument for the exploration of an idea that could pay huge dividends. So yeah, well, we'll see. As I said, it's I think there are other aspects other than just um, forces involved. I think there's some electrical things that aren't being paid attention to here. So, all right, well, cool. Let's. I want to try to get through this. I always say that I want to keep these live streams short, and here it is, almost 23 hours UTC. So it's almost been an entire hour. Secondary lobes. Oh, where's that? It's kind of weird. Whenever I zoom in, it bounces me around a little bit. In the C4 galaxy, NGC 2639. One band. Ultralight dark photon. Ice cube upgrade. Markarian 421. Synergy with velocity gradients and polarization studies. Huh. Don't know what that's all about. Most of these papers, always, and to me, to you, to most professionals, these papers go just fly over everybody's heads. So but I think it's really important in this live stream that we do as much as we possibly can to elevate ourselves. Okay, don't try to simplify and make things easy. Let's push ourselves. Let's reach a little bit. And most things are very complicated, and to simplify them actually sort of retracts from how awesome they are. So I'm not really into simplifying. I like to look at the hard stuff and go from there. Nuclear equation of state, universe. Measurement of diffuse. I'm not really seeing a lot that's really grabbing me all that hard. Um, Tools for exoplanetary transits around host stars. So this is some kind of a software package. Yeah, it looks like a Python package. Everybody's into those these days. Python is a great programming language. Comparison of the deep atmospheric dynamics of Jupiter and Saturn in light of the Juno and Cassini gravity measurements. Chemical abundance of field halo stars. ALMA, that's it's a radio observatory, big radio observatory down in South America, I believe. Blazars. Quasar Project. Wow, lots of papers today. We're already up to number 55. So carbon monoxide observations here of a gas-rich debris disk. Using sounding rockets to make observations. That's been going on at least since the 40s or so. So that's a great thing. Back reaction on an infinite helical cosmic string. Interesting. High resolution extinction map. So extinction is just is a measurement of the stuff between us and an object. So, you know, if you think you know the characteristics of that object, you know, how bright it is, say, you know, intrinsically bright it is, then you can make a measurement and say, okay, well, if there's nothing between us and it, it should be this bright. But when you know they make a measurement here, they're probably not seeing that. It's probably fainter. I don't know if it could be brighter. It could definitely be fainter, and you know, depending on how much fainter, you can sort of get an idea of the stuff between us and it. So that's what extinction is all about. That kind of extinction, at least. Abundance elements of 16 elements and 6 million stars. Holy moly. So yeah, you know, another crazy huge data run here. Kind of cool. And yeah, you know, the only way to really get that kind of information is using spectroscopy. So, you know, you spread the light out, you look at the different elements in there, and yeah, pretty cool. Well, this just keeps going on and on and on today. And I'm yawning and yawning and yawning today. Interstellar plunging waves. Black hole merger rates. Image processing in Python with montage. Lyman alpha. Lyman alpha is an emission of hydrogen. Lyman alpha starts in the ultraviolet. I don't remember exactly what wavelength. Oy vey. I'm going to have to have a little chat with my coworker. So, all right. Cool. Okay, so Nietzsche is saying that Lyman alpha is at 1216 angstroms. So cool, cool. Yeah. All right. Let's try to get through this here. You know, it is totally amazing. Sometimes there are, you know, as few as about 40-ish or so new papers. Sometimes there's 80 or 90. So who knows? We're already up to 68. Let's see how far it goes. It shouldn't be too much longer. Vortex fiber nulling for exoplanet observations. That sounds kind of interesting. Oh, there we are. We're at the end, number 71. So, all right. Well, you know, there were a few things there that were moderately interesting. I'm going to go back to the main view. Watch this. Ready? All right. So yeah, you know, there were a few kind of interesting things there. Nothing incredibly exciting or anything. All right, well, cool. Well, I think I'm going to end this for now. Got to think about this format a little bit more too. But yeah, you know, I think for the time being, it's sort of going to be like it was. Yeah, we'll see how all this goes. Um, Definitely getting back into it here. It's not going to be a daily thing because I'm not going to be here every day, but it will be here as often as I am, which is, I guess, going to sort of be confined maybe to weekdays. I'm not actually here every weekday either. So yeah, we'll see how all that goes. And you know, what it's about really is just sharing the passion, talking astronomy and space and science for a while with a bunch of friends. So that's what it's all about. All right. Well, I've got a little bit of this left. So cheers. And for now, I think I'm going to get out of here. So I think what I have to do is end the live stream over on YouTube. All right, so I'm going to do that now. So I'm going to say peace, cheers, and all that. And I will see you. I should be here tomorrow. Same time, same place, 22 hours UTC. That's a double two. I like it. 22 hours UTC. I will be back here once again with just more astronomy. We'll sort of keep doing what we have been doing, but you know, with these new capabilities, there might be more options. So yeah, we'll see how all this goes. For now, I'm going to get out of here. Peace, cheers, and all that, everyone. I will see you next time. One spin of this little tiny planet, traveling very, very fast. We don't even know it. It's super smooth. Hang on to your hats anyway. All right, everybody. Take care. Bye.